Hello, in today's lesson we're going to be doing 8F, where we can find a specific term in a sequence modelling geometric growth or decay. And by that I mean back in 8E, which we found a little bit tedious because remember how we had to press the initial amount in 6,000 and press times by 1.042, enter, enter, enter to find how many years and if it exceeds 8,000. All that sort of painful stuff in the CAS. In this one, we can find just a specific year or term or month or whatever in the sequence. And it goes like this. Here's an example. We invest 2,000 in a compound interest investment paying 5% interest per annum, compounding yearly. If we let Vn be the value of the investment after n years, we can use the following recurrence relation to model this investment. This is from the old style we just did in 8E. The initial amount, to find the next year's worth, it's 1.05 times the previous year. So that's where we'd have to press enter, enter, enter. And it looks like this. Following this pattern, after n years interest has been added, we can write. So this is what I've just written here. To find a specific year, the rate is now put to the power of the year. So the difference is this. This is the same rule, but it can be rewritten like this. Vn, you'll notice, so you can find whatever year you want, equals 1.05, which is that 1.05 from here, to the power of n. So if it said the fourth year, I'll put a 4 there, and times it by the initial amount. With this rule, we can now predict the value of the nth term in the sequence without having to generate all the other terms first, which is brilliant. So that's just what I've explained here as well. To find the nth term, it's just that R, which we've learned about previously, multiplied by the principal, which is V0. And it gets us to compound interest loans and investments. I don't know what rule you guys were taught with, but the old rule for compound interest used to be the amount equals the principal, in brackets, 1 plus the R over 100. Remember, the 1's to retain the principal, the R over 100 is the interest rate to get the interest amount, times by the amount of terms, whether it's monthly, yearly, quarterly, whatever. And it looks very similar to this still. The P is now the V0, which is just on the other side of the bracket, which doesn't mean anything, and the rest is the same. And the A is now Vn, the amount. You can read the rest of that, pretty straightforward. And compound interest, you'll notice, has a plus in the middle here, an addition sign, and reducing balance depreciation, two very different words, but the only difference is there's a subtraction there. So let's have a look at this example first of all. Example 19. Using a rule to find the value of an investment. The principal value of $10,000 is invested in an account earning compound interest at the rate of 9% per annum. The rule for the value of the investment after n years Vn is shown below. Vn equals 1.09 to the power of n times 10,000. So let's do this. I might do this on the CAS with you. So we've got 1.09 to the power, which is the up arrow. We want to do 4 years. That's good. Press across. Got an equal sign. And we're going to do 10,000. There's our amount. So I'd have to go to 2 decimal places for that. I'd have to change it. And if you have a look here, 8.816, so it's going to be 0.82. That's the amount there. And you'll do the same thing for part B. Find the amount of interest earned after 4 years, correct to the nearest cent. So if the interest earned after 4 years, if that's how much he invested, that's how much it's now worth. What do you think is going to happen? That amount, take that amount, isn't it? Which is going to be the 411 exactly. Big number, take little number. Now, this next question is very similar to the last video. Find the amount of interest earned in the 4th year, correct to the nearest cent. So, this is what we found in the 4th year. To find out how much he's earned in the 4th year, we have to find out how much he's earned in the 3rd year. And I'll explain why as I type this in. Remember, press across for this part, times 10,000. Now, the difference between these two numbers, that's the 4th year's value minus the 3rd year's, because you only want to find that money he's made during that 4th year, just 1 year's worth. So that's when they say the 4th year in this case, you've got to find the 3rd year value plus the 4th year value, find the difference between them. If they said the 7th year value, you'd go the 7th year up here, the 6th year, and find the difference between those two values. And you should see down here that that's what they've done there, haven't they? So they've seen the difference between the two. And which leads us to the last example, or last two. If the interest compounds monthly instead of yearly, write down a rule for the value of the investment after n months. So this one here I'm going to take you through with this. So remember from our previous exercise, that 9% has to be divided by 12, which gives us 0.75%. So what we've got here now is this. We've got the 1 plus that 0.75 divided by 100, which gives us this new amount, which is fantastic. And then if they want us to find out after 48 months, which is 4 years, which is way back up here, what we have to do there, the investment after 4 years, because it's now in months, we have to now put 48 to the power of that. It seems like a lot, but have a look how small this number is here. And the opposite to growth is obviously decay. And with geometric depreciation here, what's going to happen, it's called the reducing balance, which we've gone through a couple of times. And in this case, the number's less than 1, which means it's going to reduce, doesn't it? So a computer system costs $9,500 to buy and decreases in value with reducing balance depreciation of 20% each year. A recurrence relation that can be used to model the value of the computer system after n years, Vn, is shown below. V0 is the initial amount. Vn plus 1 is 0.8, because remember, 100% take 20% is 0.8, which is 80%, times Vn. So write down the rule for the value of the computer system after n years. So what I've got here, I've got this rule, which is Vn equals 0.8 to the power of n times the initial amount, which is 9,500. Very, very straightforward. Part B. Use the rule to find the value of the computer system after 8 years. Write your answer correct to the nearest cent. You've done the hard work in A. Now B is the easy part. Just put an 8 there where you want the 8th year. Power of 8 times it by that gives you the value. See how it's going down in value because it's getting smaller and smaller and smaller. And the nearest cent, remember 2 decimal places. And calculate the total depreciation of the computer after 8 years. This is different to the previous example. They want the total depreciation. So you've got the initial amount minus what it's now worth after 8 years, which means it's lost this amount over that time period. And the last few things I've got to show you, okay, and this is very important. How many years? So this is where we're trying to find n. How many years will it take an investment of $2,000 paying compound interest at 6% per annum grow to above $3,000? Write your answer correct to the nearest year. So you have to get your rule sorted out first of all. And our rule was, in this case, we want $3,000. We know what the interest amount is. We don't know what n is yet though, do we? And we know what the starting value was, V0. So this is a solve function in your CAS. So remember, menu, algebra solve. 3,000 equals that amount, n, we don't know how many years it's going to be, times the 2,000, find it for n, which was 6.9585 in this case. So that's in the 7th year because it's past the 6th year, it's now 6 point whatever years, so it's in the 7th year, so we write after 7 years. And it's the same thing now for this value, which is used to be pretty tricky doing it by hand, finding the R value, the interest rate. An industrial weaving company purchased a new loom. That's sort of sewing terms for those who don't know what that is, at a cost of $56,000. It has an estimated value of $15,000 after 10 years of operation. If the value of the loom is depreciated using a reducing balance method, what is the annual rate of depreciation? Write your answer correct to 1 decimal place. So, we know what the starting amount is. We know what we want it to become, all right, what it is. It's got an estimated value of $15,000 after 10 years of operation, all right, so n's going to be 10. We're going to work out the rate, how much the rate's been going down by. So that's the new value That's the R we don't know. We know it's been going for 10 years. That's our initial amount. We want to find it for R. And you'll get two values here. Just take the smallest one of the two. So that means it's been reduced by 12.3% every single year. That's the depreciation. It's obviously not going to be 187%. Let's get to some questions. That was a lot of examples there. Writing rules for the nth term of a sequence generated from a geometric recurrence relation. So, here, and we've got to find the value of V4 in each of them. So, starting point, it was 2 times the previous term. So what's going to happen now is this. We've got Vn, because we want to find a specific term, it equals. We know it's 2 times something. So it becomes 2 to the power of the nth term multiplied by the starting term. So when we fill this out, V4, put a 4 where we see the two n's, 2 to the power of 4 times 6 is 96. And I've done D also. So in this case, I should add a little equal sign in there. Vn equals 0.25 to the power of n, because we want to find the specific n, multiplied by the initial value. And 0.25 to the power of 4 is going to be a very small number. You multiply that by 80, and it's going to give you that value there. Here's question 2. The value of an investment earning compound interest every year is modelled using the recurrence relation. Starting value 3,000. The next year is 1.1 times the previous year. Now, with this part here, how much money was invested? 3,000. That's just a gimme question, isn't it? Next thing, this is also a gimme. What is the annual interest rate for this investment? Remember, the 1's got nothing to do with the interest rate. That's to retain the principal. So the 0.1's worth 10%. So 1.1 is 110%. The 1's the principal, 100%, and the 10% is the extra, which is the interest rate. Part B. Write down a rule for the value of the investment after n years. So I've just written that around the wrong way there. So what we got here, Vn equals 1.1 to the power of n times the 3,000. Use your rule to find the 5th year, all right? So put a 5 where you see the n, which gives us that amount. I just did all that in the CAS. And part D, what does your answer in part C represent? It represents the value of the investment after 5 years. They just want you to tell us what that 5 means. And it's as simple as that. And I've got a couple more questions I want to show you. Using a rule for the reducing balance depreciation. So this one we're going to go down. The value of a stereo system depreciating annually using reducing balance depreciation is modelled using the recurrence relation. It cost $1,200. And it's going to be multiplied by 0.88 every year. So that means 100% take away something. That something is going to be how much it's losing in percentage value every year. So 100% take 12% was the 88%. Purchase price was the $1,200, straightforward. Part B, write down a rule for the value of the stereo system after n years. So Vn equals the 0.88 to the power of n times the 1,200. This all becomes routine if you keep practicing it. Part C, use the rule to find the value of the stereo system after 7 years. Where the n's were, put a 7. 0.88 to the power of 7 times the initial amount. It's now worth $490.41. And I did question 8 as well. Sarah invested $3,500 at 6.75% per annum. If the investment now amounts to $5,179.35, how many years was it invested? I just wrote the rule out first of all to try and not make it as confusing. So Vn 1.0675 for the percentage to the power of n times the initial amount. And then we can find out n, like in the example, with the solve function. That's what it's now worth. That's the rate to the power of n, we don't know what that is, times the 3,500, comma n, gives us 6 years.